Hey there, science fans! Welcome to another exciting journey into Tech-Mech Explanation. Have you ever thought about the incredible power of the sun? This massive, glowing sphere in the sky is more than just a source of light and warmth. It's amazing to think that this giant ball of hot gas composed mainly of hydrogen and helium is the source of almost all energy on Earth. The sun's nuclear fusion reactions release an immense amount of energy, which travels across space to reach us. That's right, from the food we eat to the fossil fuels we burn, almost everything can be traced back to our very own star. Plants use sunlight to grow through photosynthesis, and ancient plants and animals transformed over millions of years became the fossil fuels we use today. But here's the really cool part. We can harness the sun's energy directly using solar power. Solar panels capture sunlight and convert it into electricity, providing a clean and renewable energy source. Imagine a world where we rely less on fossil fuels and more on clean, renewable energy from the sun. This shift could significantly reduce our carbon footprint and help combat climate change. That's a future worth striving for, and it all starts with understanding how solar energy works. By learning about the technology and science behind solar power, we can make informed decisions and support sustainable practices. So buckle up, because we're about to take a deep dive into the fascinating world of solar energy. We'll explore the science, the technology, and the potential of this incredible resource. We'll explore how it's produced, how we capture it, and why it's so important for our planet's future. From photovoltaic cells to solar thermal systems, we'll cover it all. Get ready to be energized. Together, we'll uncover the secrets of solar energy and discover how it can power a brighter, cleaner future for all of us. Now, you might be wondering, how exactly does the sun's energy reach us here on Earth? It's a fascinating journey that begins deep within the heart of our star. Well, it all starts with a process called nuclear fusion. This is where the magic happens. Deep inside the sun's core, hydrogen atoms are constantly colliding and fusing together, creating helium and releasing enormous amounts of energy. This fusion process is what powers the sun and produces the light and heat we feel on Earth. This energy is in the form of tiny packets of light called photons. These photons are born in the sun's core and begin their long journey outward. Think of photons as little messengers carrying energy from the sun. They travel through the sun's layers, bouncing around in a chaotic dance that can take thousands of years to reach the surface. Once they escape the sun's surface, these photons travel at the speed of light, zooming through the vast emptiness of space for about 8 minutes before reaching our planet. This journey is incredibly fast, covering 93 million miles in mere minutes. It's like a cosmic relay race, with photons passing the energy baton all the way from the sun to Earth. When they finally arrive, they bring with them the warmth and light that sustain life on our planet, making it possible for plants to grow and for us to enjoy sunny days. Once those energetic photons arrive on Earth, we can capture them using solar panels. These panels are like giant energy sponges, soaking up sunlight and converting it into electricity. Pretty neat, huh? It's all thanks to the magic of photovoltaic cells, which are the key components of solar panels. You can often find solar panels on rooftops, soaking up those rays. But they can also be used in larger settings, like solar farms, to provide power to entire communities. Photovoltaic cells are made from special materials, usually silicon, that have a unique property. When sunlight hits these cells, it knocks electrons loose from the silicon atoms. These freed electrons then flow through an electrical circuit, creating an electrical current. It's like a tiny game of pinball, with photons acting as the pinball and electrons as the points. Photovoltaic cells are designed to maximize the capture of sunlight and the flow of electrons, making them highly efficient at converting solar energy into electricity. Section 5: DC to AC inverters at work. Here's the thing, solar panels produce direct current or DC electricity, but most of our appliances run on alternating current or AC electricity. So how do we bridge the gap? Enter inverters. These clever devices act as translators, converting the DC electricity from solar panels into AC electricity that our homes and businesses can use. Inverters play a vital role in making solar energy compatible with our existing electrical grid. They ensure that the electricity generated by solar panels can power our lights, appliances, and everything in between. Section 6: Storing sunshine. The role of batteries. Now what happens when the sun isn't shining, like at night or on cloudy days? Don't worry, we've got that covered too. Solar energy systems often include batteries that store excess electricity generated during sunny periods. This stored energy can then be used when sunlight is limited, providing a continuous power supply. Batteries act like energy banks, saving up sunshine for a rainy day. They allow us to use solar energy even when the sun isn't directly shining, making it a more reliable and resilient source of power. Section 7. Types of solar panels, a colorful variety. Just like there are different types of cars, there are different types of solar panels, each with its own unique characteristics. These differences can significantly impact their performance, cost, and suitability for various applications. Let's meet the main contenders: monocrystalline, polycrystalline, and thin-film solar panels. Each of these types has its own set of advantages and disadvantages, making them suitable for different scenarios. Monocrystalline panels are the most efficient type, made from a single high-purity silicon crystal. This high efficiency means they can convert more sunlight into electricity compared to other types. They tend to be a bit pricier but offer the best performance. Their sleek, black appearance also makes them a popular choice for residential installations where aesthetics are a consideration. Polycrystalline panels are made from multiple silicon crystals, making them slightly less efficient but more affordable. They have a blue, speckled look and are a great option for those looking to balance cost and efficiency. And then we have thin-film panels, which are lightweight and flexible but have lower efficiency compared to their crystalline counterparts. These panels are ideal for unconventional surfaces and applications where weight and flexibility are crucial. Depending on your budget, energy needs, and available space, you can choose the type of solar panel that best suits your requirements. Whether you prioritize efficiency, cost, or flexibility, there's a solar panel out there for you. Make sure to consider all these factors when making your decision to ensure you get the most out of your solar investment. Section 8. Setting up your solar system, installation and maintenance. Installing a solar energy system might sound complicated, but it's a well-established process. Qualified solar installers will assess your energy needs, design a system that fits your roof or property, and handle the installation from start to finish. Once your solar system is up and running, it requires minimal maintenance. Regular cleaning to remove dirt and debris, and occasional inspections to ensure everything is in tip-top shape are usually all it takes to keep your solar panels humming along for years to come. Section 9. A brighter future. The environmental benefits of solar energy. Now let's talk about why solar energy is such a big deal for our planet. Unlike fossil fuels, which release harmful pollutants into the air, solar energy is a clean and green source of power. By harnessing the sun's energy, we can reduce our reliance on polluting power plants and create a healthier environment for everyone. Solar energy helps combat climate change by reducing greenhouse gas emissions. It also reduces air and water pollution, protecting our ecosystems and public health. And because sunlight is a virtually inexhaustible resource, solar energy offers a sustainable path for future generations. Section 10. Solar energy in society, a positive impact. But the benefits of solar energy go beyond just the environment. Switching to solar power can also have a positive impact on communities and the economy. As solar energy becomes more popular, it creates new jobs in manufacturing, installation, maintenance, and research. This booming solar industry helps boost local economies and provides new opportunities for workers. Solar energy can also increase energy independence, reducing our reliance on foreign energy sources. It can provide power to remote areas that are not connected to the grid, improving access to electricity for underserved communities. Section 11. Join the solar revolution. We've covered a lot of ground today, exploring the ins and outs of solar energy. From the sun's nuclear fusion to the workings of photovoltaic cells, from inverters and batteries to the environmental and societal benefits, it's clear that solar energy is a game changer. As we look towards the future, embracing solar energy is not just a good idea, it's essential. By choosing solar, we can reduce our carbon footprint, create a cleaner and healthier planet, and build a more sustainable future for generations to come. So, let's join the solar revolution and harness the power of the sun together.